Howdy guys, this is just a quick video kind of breaking down what's going on as far as the individual energy systems and how they're going to be related to what's going on when someone's being physically active. So we have right here is going to be effectively the amount of energy that someone's going to be able to produce when they happen to be doing something like maximal exercise for 6 seconds, 30 seconds, 60 seconds. So 6 seconds would be most people running 40 to maybe 50 yards. If they're really quick, some folks might not even make it to 40 yards during that time. 30 seconds would be effectively someone trying to do like a maximal 200-yard sprint, give or take. 60 seconds would be running nearly a quarter mile for most people. Obviously, some folks even further than that. 120, now we're talking about really great athletes running 800s. Max speed you can maintain for a full hour, so that's going to be something along the lines of getting into running a 10K to maybe a half marathon if you're just a beast. And then you can talk about 4 hours and then 4 frickin' days. Now, notice the colors of the bars change. So we're always using every single energy system. The key is which we're emphasizing. So we can obviously produce energy far more rapidly from our ATP and phosphocreatine PC systems. Those, however, exhaust out pretty quick. So that's why we see a massive drop off in the energy production rate once we're going to 30 seconds of maximal effort. And then we see another slight drop at 60 seconds and an even greater drop when we're getting ourselves to 120 seconds because, well, it turns out we have not only fatigued out our ATP PCR system, but we are also not able to keep up that output with anaerobic glycolysis as much anymore. So that's why we see another drop when we get to 1 hour, where you're running it mostly off of aerobic metabolism, with obviously still everything going on. The one that happens to be the largest is beta oxidation, so using fat as a fuel. And if we're going for 4 hours, you see how fat becomes an even bigger factor in the matter. Now, these bars are not perfect. There's obviously going to be some sway. There's effects of due to your nutrition, your training status, and otherwise they're going to influence which of these fuels you're going to use. And if we're talking about, I don't know, walking 4 days without sleeping, which I guess if you like the book The Long Walk and you want to live it, cool, not for me, but that's going to be mostly done through beta oxidation. Now notice there's deamination, which is going to be using protein as a fuel. It doesn't really happen too much. It's a very rare occurrence in most athletic endeavors, which brings us to our next graph where we can see how these energy systems are going to contribute. Now, I realize I am not having this sized well enough, so you can see my happy face in the middle now, because that's not weird at all for you guys to have to stare at, where you can see the total amount of calories you're going to burn over those 4 days is insanely high compared to the amount that you're going to be burning over 4 hours, 1 hour, and then notice we can't even see anything because we're talking about if we did that without taking a break for 4 days of hard work, we're talking about a potential of 900,000. I believe this is in joules as far as the energy total production. Now, if we go and we then modify this so we can view it relative to the individual bars, we can now see how we have that initial major contribution from our ATP system. This is logarithmic, so it's noticed as 1, 10, 100, 1,000, and so on. So hence the bars don't look like they shift too much, but what's kind of neat is you can see how the contributions of the total amount of energy are going to be shifting down. Now, if I did this perfectly, which I did not, you would see how the blue line would be the same height for all of these. And then the orange line would be the same width for all these. And then we see how it stacks and stacks and stacks to where, notice it doesn't look like we're using a lot of fat, but notice that's the difference between 1 million and 10 billion. And that's where fat becomes an even bigger factor. So when we're talking about energy system demands and we're talking about how much the body is going to utilize each system, this is another way to look at it aside from those raw percentages of you can see that breakdown. So thanks for listening, guys. Have a great day. If you have any questions, comments, concerns, please leave it below. Bye-bye.